Hi students, this is Shivakrishna, working as a assistant professor in civil engineering department, uh, Anurag Engineering College. Now I am explaining about the columns. Previous classes we have to discuss about the design of beams and design of columns. Now coming to the topic of design of columns. What is the column? Column it is structural member and you have to use the design to carry the compressive loads composed of concrete within the embedded steel frame to provide the reinforcement. These are various types of RCC column based upon the shapes, length and forces. Functions and construction methods are discussed here. Column it is a vertical number. It takes place complete load on the beam, slabs and their entire structure. The floor and other area of building is adjusted as per the requirement of the client or owner. The size of the columns, quantity of the cement, sand, aggregates, it should be mixed and the number of steel bars to be placed, spacing between the stirrups, it all mentioned in the structural drawing which is designed by structural designer as per the actual load on the column and it should be applied some factor of safety. And what are the types of columns? Based upon the types of columns, it should be categorized into three different types. That is, one is based upon the shape and based upon the length and based upon the movement. Coming to shape, these are the four types of shapes generally we are constructing in the nowadays. That is square columns, rectangular shape, circular shape, and polygonal shape. Square shape. In the square columns, the square column should be generally provided in residential buildings. It is very easy to construct on that particular location. And rectangular columns, it is used where the space is limited in that particular location. It should be carry heavy loads. In the type of situation, rectangular columns have to preferred. After that, circular columns. In the circular columns have to provide the aesthetic appeal and distribute the loads evenly. And polygonal, it is the architectural features only we are using the polygonal columns. And coming to based upon the length and width to height ratio, it should be maintained less than 12. The type of columns are under short columns. Where that ratio should be maintained greater than 12, that type of column should be categorized mm, into long columns. And based upon the moment, based upon that slenderness ratio, this slenderness ratio, it is what is meant by slenderness ratio means it is the effective length to least radius of gyration here consider. Based upon the effective length, how to find the effective length on that particular column. Columns are different types. One is the fixed and one is the free and one is the fixed and free. This type of phenomena will be occur on that particular location. In that type of location, I have to effective length should be vary in that situation. When we are providing the column at fixed ends, we L effective equal to half of the length, that is L by 2 we have to prefer. And pinned or hinged means that is L equal to L, the same length should be provided on that particular location. And after that, one is the fixed and another one is the free. At the type of situation, effective length equal to twice of the length you have to prefer. Next, coming to radius of gyration, that radius of gyration, it is the ratio of moment of under root of moment of inertia to area of that section. And next one, based upon the moments, the column should be, we apply the moments as three types, that is axially loaded columns and uniaxial columns and biaxial columns. Coming to axially loaded columns, the axially loaded columns, this should be short columns. It should be primarily axial loads. Exactly, neutral axis should be carry the loads, and there should be slenderness ratio maintained as the it should be very low, that is less than 12 only how to maintain. Next, bending. Based upon the bending situation, uniaxial and axial, biaxial, it should be considered here. That is, the bending should be taken as only one direction, that is called uniaxial, and biaxial means the bending takes place in both the direction of that particular column, that is called biaxial. And next one, this is the type of list of figures shown the axial loading, uniaxial and biaxial moments, where the load acting on that particular neutral axis, that is called axial loads. And the second figure, the load should be acting some eccentricity here takes place. That eccentricity, that load into distance we have to maintain, that movement should be acting on that particular location, that is called uniaxial. And biaxial means the eccentricities will be applied on that along x direction and along y direction. This type of situation, it is called biaxial movements. And coming to design of axially loaded column, axially loaded column means it is a short column and less than standardized ratio 12. So we have to fulfill on that all parameters. We have to find out the design. Here taken one example problem. Here the column size is 450 by 600. The load acting on that column is 2000 kilonewtons, and the column has unsupported length 3 meters and braced against sideway on the both directions. Here the use of concrete is M20 and use of steel is Fe415. Here first of all, the column is short or long, that should be have to find out. Based upon the standardized ratio only, you have to find out the short column or long column. The standardized ratio, it should be less than 12, it should be coming up to short column, and more than 12 it should be considered at the long columns. And after one more check, that is the eccentricity, that is it should be axial loaded column or biaxial or uniaxial. For the checking, we are using the minimum eccentricity. That formula I have to use L by 500 plus DRBR3 by 30 and 20 mm. When we are using the minimum eccentricity, at least 20 mm we have to prefer. In this criteria, whichever the greater value, it should be taken into account. From this, one is the 26 is the getting on that equation, and one is the 20 mm. We have to minimum, we have to provide 20 mm only, we have to take that value 26. And after that, the 0.05 times of d, it should be greater than 20. So we have to find out this formula decided to. This is the axially loaded column member. After that, you have to find out the area of steel, it should be occupied in this particular column. By using this formula, you have to find out the area of steel in the compression phase. This is the formula for using the area of steel, that is 0.4 FCK AG plus 0.67 F5 minus 0.4 FCK ASC. PU means that is the factor load. In the problem, we are given the working load into 1.5, how to did that, we are getting the ultimate load. And after that, we have to substitute that all values and find out the area of reinforcement, that is 3,311, you have to getting the value. Here that total ASA we have to convert into number of bars. In that situation, you have to assume the some diameter of bar. The diameter bar, it should be divided into how many number of bars should be provided on that particular column. Here we are using the 25 mm diameter of bar, and should be have to use 4 number of bars, it should be taken place on that particular location. After that, the transverse reinforcement, that is called lateral ties. This lateral ties, I have to find out the diameter of the tie and what is the spacing between the ties I have to provide. What is the diameter of tie here? Two criteria I have to find out, that is the pi by 4 or diameter of the bar by 4 or 6 mm, whichever is greater value, that should be considered here. And the spacing should be 3 criteria. One is what is the least dimension, and 16 times of diameter of the bar, and 300 mm. In this greater value or lesser value, you have to consider here. Lesser value is 300 mm, we have to provide it. This is the reinforcement, that is we are using the 8 mm bar at 300 mm center to center ties. We have to find out, we have to used in that particular design for bearing of the load. And coming to uniaxial bending, uniaxial means the load acting with some eccentricity. That type only we have to use the using that particular situation. A column subjected to vary magnitude p, and the moment will act as its neutral axis at varying points. After getting that values, I have to find out the moment and the load. By using this is the chart SP16 charts. We have to use the P by FCK value. Here the curve shown as the P by FCK compression failure, and x-axis it should be shown as a mu by FCK BD square, and y-axis it should be PU by FCK B into D. For taking in the circular column, in the B place I have to replace it with D. In that particular location, mu by FCK BD D cube and PU by FCK D square. I have to use that formula and find out the x-axis value and find out the y-axis value. Where that is location on that particular graph, the common point where should be located on that particular curve, that curve that gets the value of P by FCK. FCK is the characteristic compressive strength of concrete. P is the area of steel I have to find out. After getting that value, FCK will be sharing on that out of that equal. We have to find out the percentage of the steel. And after that, biaxial movement. In this biaxial movement, three different movements should be acting on that particular column in the x-axis along y-axis. So two movements should be appear in that particular situation, that is MUX and MUY. After that, this MUX and MUY values should be compared to permissible values of MUX1 and MUY1. This all values should be ranged in the less than or equal to 1 only. After that, the code further related to the by using this chart, that is the PU by PUZ, and the second one is the PC value, and both which line it should be coincide on that particular line, that value I have to find out the area of the steel on that particular situation. And after that, this three type of criteria we have to use in that short columns, that is one of the axial load column, and second one is the uniaxial column, and the third one is the biaxial column. In the overview in that short columns, the load acting on that neutral axis, that is called as axial load columns, and the load acting with some eccentricity along within either x direction or y direction, that is called uniaxial columns. And biaxial means the load acting with some eccentricity along with x-axis and y-axis, it is called biaxial columns. After coming to long columns, what is the long column? The maintaining the slenderness ratio greater than 12. That maintain the greater than 12, it is comes under long columns. That is also you have to consider the along x-axis and y-axis. From the scenario, we are stepwise you have to find out the design of columns. That is, first of all, you have, that is, this is the formulas for using the moment on that particular long columns. That is PU into D by 2000 LEX. LEX means along x direction what is the length by D whole square, and along y direction moment is PU into B by 2000 into LEY by B whole square. By using these formulas and find out the moment along the x direction and y direction. In this step 1, first of all you have to find out the effective length and slenderness ratio of that each direction. Why? Because this slenderness ratio only decide the is it is long column or short column. And after that, in the coming to step number 2, determine the moments in the primary moments of each direction. After primary, we are adding the extra moments, that is called its headstand moment we have to use on the particular situation. Calculate the E minimum and M bending moment in that each direction. Compare these moments and computed the steps in the above. Take care the greater one of the two initial moments, that is in each direction. After that, compute the additional moment acting on that particular column. That should have only we have to provide the extra movement and extra bars and extra area of the steel. Why? Because long columns you have to greater load you have to carry on that particular situation. So that's why only you have to using the particular situation, that is pu by d 2000 le x by d whole square and pub by 2000 ley by b whole square. And after that, this is the total outline of that design of columns. Actually outline means columns, it is a structural member, it carries the compressive loads. For bearing of that compressive loads you have to design of that column. How much area of steel should be provided on that column, it should be greaterly designed. Here types of columns, it should be based upon the Sneddon's ratio. It should be categorized into two columns, that is short columns and long columns. Short columns should be fails by crushing and long columns should be fails by buckling. Here the effective length should be support conditions, it should be acting on that payment acting on that columns, it should be calculated based upon the Sneddon's ratio. And after that, based upon the movements, axial load column, uniaxial and biaxial movements, you have to use by using SP16 means special publication charts you have to use. And find out the P by FCK. From that P by FCK value we have to getting the value of percentage of steel should be acting on that particular column. After one diameter of the bar you have to assume should be divided into number of bar should be used in that particular situation. Thank you students.